All right, we are on the second part of our review for test 2. I'm on number 16 here. It says, suppose you want to retire in 30 years and be a millionaire. If you can earn an interest rate of 9.5%, which is quite aggressive, it would be pretty impossible to find that right now, but we're going to go with that for this problem. Notice we're compounded monthly. How much must you put in an IRA each month in order to meet your goal? Round to the nearest dollar. All right, so this is similar to the last problem we did where we have a financial goal. And we're dealing with regular payments because it says it's compounded monthly, and we're going to be putting money into this IRA account each month. So in this problem, n equals 12. Notice our time is 30 years. Our interest rate is 0.095. And again, that's kind of a dream rate right now. So again, we're trying to reach a million, or actually in this case, let me look back on that last one. I want to make sure I didn't say that incorrectly. No, actually on 15 it was the opposite, because they told us what P was, our monthly deposit, and we had to find the future value. In this case, the future value, or what we want it to be, is $1 million. We need to find P, and so that's going to be this one here. So again, it's an annuity because of the regular payments. In our case, it's going to be 12 times a year. We have a financial goal, $1 million. We want to make $1 million in 30 years. So we need to know what our monthly payments need to be, our present value. It's not really present value, it's more just your payment values, what you're going to have to put in each month. So let's go ahead and write that formula down. Hold on just a second. So we have P is equal to A times R over N. And in the denominator, parenthesis, 1 plus R over N to the NT power minus 1. Notice we want to be a millionaire, so that is our A. It's $1 million. Make sure you put enough zeros. So that would be $1 million. And then, so that'll go here. That's our A. Times 0.095 over N, which we said it was compounded monthly, so N was 12. And that's over parenthesis, 1 plus 0.095 divided by 12 to the 12 times 30, it's 30 years, minus 1 into parentheses. So that's what we're going to put into our calculator. So our numerator, let's make sure you're cleared. Our numerator is going to be 1 million. So 1, 2, 3, 4, 5, 6 zeros. Parentheses 0.095. Fraction button 12. End of parentheses. Now we're into the denominator. Parenthesis, 1 plus 0.095, fraction button 12, parenthesis, and then don't forget your exponent button, 12 times 30. Let's get out of the exponent and put in the minus 1 and in a parentheses. Whew, that's a lot. So that's, again, as you're putting the numbers in, you could just kind of make sure everything is correct. You can see part of this right here. let's go ahead. Other thing to do is just to be real careful. You can always go back and re-enter the numbers and just make sure you're getting the same answer. So we get 491.88. 491.88, that's about $492. So if you were able to earn 9.5% interest, that's what you would have to put in. Now you could come up with some kind of investment type of thing where you're investing into the stock market in special types of funds, and you could probably get something between 6 and 8% over the long run, but again, 9.5% would be pretty large, and normally it's not going to be set for 30 years. But anyway, so that's the basic idea though. So obviously right now you'd have to pay more than $492 a month for 30 years to become a millionaire. And in fact, maybe $1 million may not be enough in 30 years. So who knows, but it'd be a good start. Okay, it says, of that amount, how much will you have contributed and how much will be interest? Well, you're paying $492 each month, so that's 12 months a year, for 30 years. And so your contribution is going to be $177,120. So if you want to know what your interest was, it's $1 million minus $177,120. When you subtract there, you get $822,880. That's interest. That's a chunk of change there. So that's a great amount of interest. So again, you can see why the higher interest rate you can get, the better off you will be. If you put in, I don't know, maybe something more conservative like 5 or 6%, you'll see that you have to contribute a lot more and your interest will not be as much, but you'll still see that your money grows even if your interest rate is smaller. It's just not going to grow quite as great as it did here. All right, let's move on to number 17. It says, suppose you decide to take a $34,000 loan for a new car. Compare the payment amounts and total interest paid for the following loans. Which would you choose? So we have a 3-year loan at 4.5% and a 5-year loan at 5.3%. Now right now, if you have really good really good credit, you might be able to get a loan at like 2 or 3%. But maybe here your credit's not as good, and this is what you're going to pay. And by the way, I got that $34,000 off the internet. That's the average price or the average amount that people are borrowing when they buy a new car. So that's a lot of money. All right, so we actually have a formula for payments. Let's see. It's this one here. Loan payment for fixed installment loans. What that means is we borrow money and we pay it back in fixed amounts, and it's normally per month. So that just means we're paying regular monthly payments. So our PMT, it's P times R over N over 1 minus 1 plus R over N to the negative NT power. So P here is the amount, the starting amount that we borrowed, $34,000. And we're working on this one here, so we're going to work with a rate of 0.045, written as a decimal. Our time is 3 years. So it'll be 0.045 over N. Now, because this is, you're making monthly payments here, the interest is also compounded monthly. So here, let's see. Maybe it should be more clear that it's monthly payments, but that's normally how it works when you have an installment loan like we do here. So n is 12. In the denominator, we're going to have 1 minus 1 plus, 0.045. Divide 12 to the negative 12 times t, which is 3. Now our other one is going to be exactly the same. So this is loan 1, and loan 2. So here you would have 34,000 times 0.045. No, actually that one's 0.053. Notice here R equals 0.053, and our time is 5. I'm just going to set up the 2. I'll just go ahead and do this. There's a reason for this madness here, so it'd be 0.053 over 12, and that's divided by 1 minus parentheses 1 minus parentheses 1 plus 0.053 divide 12 to the negative. Now it's 12, because n is 12, times the number of years. In this case, it's 5. So that's our exponent. So let's go ahead and do this one, and then you'll see we can actually do the other one quite easily. All right, so we've got 34,000. Let's hit the fraction button. Maybe we should have hit that first, and then parentheses 0.045, fraction button 12, arrow right, parentheses. That's our numerator, and everything's looking good. Let's go down. Parentheses 1 minus parentheses 1 plus 0.045, fraction button, over 12, arrow right, parentheses, and then hit your exponent button, and it's going to be negative. Now be careful, the negative button is this one here. So we'll hit negative 12 times 3, and arrow right. All right, so let's go ahead and see what our monthly payment's going to be there. $1,011, and didn't really say whether to round or not. We'll just go ahead and round it to 40 cents. So you can see what we have there. If you round that to the nearest cent, it's going to make that 9 move up, which will cause this to be a 4. It'll be 40 here. And so that's our monthly payment if we do the 3-year loan. And I don't know about you, but I'm looking at that amount and I'm going, wow, that's a lot of money for a car payment. I mean, a lot of people have house payments that are, not recent house payments, but payments for people that have been paying for quite a while. It's not uncommon to find a payment like that. It's a lot of money. All right, so here's the thing. We don't actually have to re-enter all that. We can just arrow up to that formula and hit enter. And then let's arrow back. Notice that 3 is going to become a 5 because now it's a 5-year loan. And our interest rate is 0.053. So we just keep arrowing to left, and then in this case I arrowed up. And we'll just type over that. It'll be 5.3. And the only other place to go is in the numerator and change that 0.045 to 0.053. So 0.053. So you can see I've changed my rates to 0.053, it was negative 12 times t, our time, which is now 5. I just got to keep arrowing. You can see it there, the 5. And so now let's go ahead and hit enter. And so now we're at 646.31. 646.31. So hopefully you're like me, you're going, that's still a lot of money. I don't really want to borrow that much if I could avoid it and pay for 6 years. Or well, this is 5 years. That's what they do these days, is they'll extend the loans. I don't know if they're going beyond 6 years, but I know they're going longer than they used to go. But that's a long time to make a car payment. You're just hoping in 6 years that car is still in great shape. But anyway, this makes it more affordable for a person. But here's the thing. It says, compare the payment amount. So certainly this one is a lot less. But let's look at what we're paying in interest. So on the first loan, let's see, how did I do this? One of the things I'll try to do on the test and make it clear as far as how to round. Let's go ahead and just round this to $1,011. And we're making 12 payments a year for 3 years. And so if you multiply that out, 1,011 times, I'll just say 36, you get 36,396. Now remember, this was a $34,000 loan. That's how much you had to borrow. So you're paying the $34,000 back and then some. If you subtract, you get $2,396. And so that's the interest that you're paying for this 3-year loan. Let's look at the 5-year loan. We'll round to 646. That's times 12 payments a year for 5 years. So let's go ahead and multiply that out. 646 times 12 times 5, and I'm getting $38,760. And so if we subtract the actual loan amount, which was $34,000, that's what we actually borrowed, and this is what we paid. If you subtract, you get $4,760. Notice we're paying more than twice the amount of interest. So the good news is we're paying a lot less each month, but over those 5 years, we're paying almost $5,000 in interest. That's a lot of money. So I think the important thing is just to be aware of what you're paying when you take out a loan. A lot of times people aren't aware and they don't realize just how much money they're spending on interest, and if they knew that, they might consider some other options. All right, let's move on to the next page, our last page. So in this problem, we're going to look at how they do your statements for credit cards, how they determine what you're going to pay in terms of interest and what your minimum payment is and all that good stuff. So you'll notice on your formula sheet that you'll have the sum of the unpaid balances for each day of the billing cycle. And I'll give you some kind of a table like this if you see this on the test. So it says a credit card issuer calculates interest using the average daily balance method, which is the method we talked about in class. The monthly interest rate is 2% of the average daily balance. So that's the monthly interest rate. If you multiply that by 12, you can see your credit card interest rate is 24% a year, because you're basically paying 1/12 of that each month. Okay, so the following transactions occur during the September 1st to September 30th billing period. And so first of all, we have to find the average daily balance for the billing period. round to the nearest cent. So the previous balance was $3,800. And so that's what it is on September 1st. So 3,800. Now on the next activity occurred on September 5th. And that's when they received my payment, or the payment for the credit card, a payment of $800. So we're going to subtract $800. And so now $3,000 is what would be owed. The next activity is on September 9th. And that $3,000, it's going to go up because we charged some gas. So we'll add $40 to our balance, and now we're at $3,040. And then there was a charge on the 19th, so September 19th. And this was for clothing. It was $160, so we're going to take $30, $40, and add $160 to that. And what's that, $3,200? And then finally, on the 27th, some airline tickets were bought. And we'll take that $3,200 balance that we had, and we're going to add to that another $200. And so we're now at $3,400. Now keep in mind the last day of the billing period is September 30th, which it tells you up here. We'll just write that right there. So what we want to do is figure out how many days we were at each balance. So from the 1st to the 5th, we were at 3,800 until the 5th. So the 1st, the 2nd, 3rd, and 4th. So for 4 days, we were at 3,800. So here, now it's at 3,000 after this activity on the 5th, and it's 3,000 from the 5th until we get to the 9th. So the 5th, 6th, 7th, and the 8th. So for 4 days, again, this time it was at 3,000. Now notice 9 minus 5 is the 4, and 5 minus 1 is the 4. So we can actually subtract 19 minus 9, and we're at this balance for, what's that, 10 days? And if you subtract 27 minus 19, that would be 8. We're at this 3,200 balance for 8 days. Now this last one's the one you have to be careful of. It's actually not 30 minus 27 because there is no activity on the 30th. So the 27th, the 28th, the 29th, and the 30th, that's 4 days. It's going to be at that amount. Notice it's not 30 minus 27 here. So you can subtract on all the others until you get to here. Now the key to make sure you didn't make a mistake is add up all your days. In September, remember it's from the 1st to the 30th. That's what it told us up here. Should have 30 days. If you add these numbers, that's 8, 18, 26, and 4 makes 30. And so you can see that we have activity for 30 days, so we're good. So now we could say, okay, 3,800 plus 3,800, we could do that 4 times, plus 3,000 plus 3,000, and again we could do that 4 times. But instead of adding 30 values like that, what we do is we take the number of days times the amount that we owed on those 4 days. And so instead of adding 3,800 4 times, we just say 4 times 3,800. Similarly, here we have 4 times 3,000, 10 times, 3,040, 8 times 3,200, and 4 times 3,400. Now I've already multiplied these out. You can verify my answers here. Here you get 15,200. Here you get 12,000. And then 30,400, 25,600, and 13,600. You add all those up and you get 96,800. So our average daily balance, which again we have a formula for on our formula sheet at the very bottom here. So this is the sum of our unpaid balances. It's basically adding the balances for the 30 days. You would get 96,800, and you divide by the number of days, which is 30. That's the formula. And when we do that, we get $3,226.67. So that's what we owed on average throughout the month, which seems reasonable if you look at our numbers: 3,800, 3,000, 3,040, 3,200. So that would seem to be an average for our balance owed throughout the month. Okay, so now let's move on to the next problem. It says find the interest to be paid on October 1st, the next billing date. Round to the nearest cent. Now remember, the monthly interest rate is 2% of the average daily balance. We just found the average daily balance. So 2%, or 0.02, times that number, $3,226.67. When you multiply that out, you should get about $64.53. Now, if you paid the $3,400 at the end of the month, or when you get your credit card bill, you wouldn't have to pay this interest. But assuming you're not paying the whole amount, you have to pay the amount in full or you'll pay this interest. Now it says find the balance due on October 1st. Well, remember, your balance was $3,400. Plus you're going to have to pay this interest for the month. And so you get $464.53. All right, so that's what you owe right now, assuming you can't pay it all in full. The minimum monthly payment is 1/36 of the balance due. So normally in most states it has to be at least 2% that you pay each month, which covers, it should pay for more than just the interest that you have to pay for that month. In this case, it's 1/36 of our balance due, which is this amount here. Of course, we're going to multiply these two numbers. So it's just multiplication here. And you get $96.24. And that's it for this problem. Now, I just want to point out what that means is you're paying about $100, and over half of that is going towards interest. So you're going to pay less than $50 down to get your balance down if you pay that minimum payment. And so that's why it takes so long to pay off credit cards if you're just paying the minimum. All right, that's it for this review. I hope you do well on the test. Let me know if you have any questions.